Electric drive vehicles are normally expected to be connected to the grid only for recharging. At AC Propulsion, we're working on how to make power flow both ways through this connection. This is a prototype vehicle with a controller allowing two-way electricity flow between the vehicle and the grid. The vehicle's grid power connection can be used for charging, as in today's electric vehicles. The vehicle is now charging at 20 amps battery current, or about 7 kilowatts. But, when allowed by the driver on a signal timed by the utility or grid operator, the vehicle can feed power to the grid, discharging the battery. Here, it's discharging at 32 amps, supplying at about 10 kilowatts. The vehicle power electronics unit handles all the two-way power control. It is connected to a standard high-current 208-volt circuit in the building. This 80-amp connection allows 16 kilowatts of power to flow in either direction. In homes, power flow would typically be limited to 7 kilowatts. This power meter illustrates how the vehicle's power flow affects the building's power consumption. Initially, the wheel spins with the normal building load. When the vehicle battery charger is turned on, the wheel spins faster. Now the charger is shut off, and the discharge function is enabled. The discharge power slightly exceeds the load in the building, so the meter spins backwards. Now the discharge is stopped. Power grid operators use ancillary services to help maintain the reliability of the grid. One of these services, regulation, is used to continuously fine-tune the balance between generation and load. Electric vehicles can be used for regulation. With a real-time wireless data connection to vehicles, the grid operator could control power to or from thousands of electric drive vehicles. Because these vehicles would be geographically distributed and respond very quickly, they may offer superior regulation services than those currently available from power plants. Vehicles can perform regulation services whenever they are connected to the grid. With vehicle-based regulation, there is a prospect of reducing regulation costs for the grid operator, increasing the available capacity of generating plants, and transforming the economics of electric drive vehicles.